In this video, we're going to go through a trigonometry test review for pre-calculus students. So oftentimes in a pre-calculus course, there will be a little bit of review of trigonometry. And so we're going to go through 25 questions that you would likely see on a test like this. So what you might want to do is pause the video, try and do these problems on your own. And of course, we'll go through them together. So let's dive into the first question. It says the point negative square root of 3, negative 1 is on the terminal side of an angle in standard position. What is the smallest angle in radians and degrees? So let's draw a sketch of this. So negative square root 3, that means that you're going left root 3 and down 1. So we're going to just draw their terminal ray. Remember the initial position, that's along the positive x-axis, and then you rotate to the terminal ray, and that's like your angle right there. Now, wherever you end up, you want to drop a perpendicular to the x-axis, always to the x, never to the y. And this side of the triangle is negative square root 3, and this side of the triangle is negative 1. If we do the Pythagorean theorem, square root of 3 squared plus 1 squared is going to give us 4, and square root of 4, the square root of 4 is 2. So you can see this is our triangle here. Now, notice if you were to divide all these three sides by 2, you would have negative square root 3 over 2, negative 1/2, and 1. This would become like our unit circle. And the point on the unit circle that corresponds to the point negative root 3 over 2, negative 1/2 is at a 30-degree reference angle, which means that this is going to be 210 degrees, okay, if we're doing the angle in degrees, or 7 pi over 6 if we're in radians. So the key here was really drawing the triangle and then recognizing that this is a special right triangle. It's a 30, 60, 90 triangle. Let's go on to number 2, 3, and 4. Here what you want to do is evaluate, which just means to find the value of these trig functions at a given angle without a calculator. So we're basically going to the unit circle and saying, what is the cosecant of 11 pi over 6? Now, I've got videos on all these topics, so if you get stuck on any of these questions here, feel free to search this up on my Mara's Math Tutoring YouTube channel. But the way I like to think of it is 11 pi over 6 is like 1 and 5/6 pi. So I'm going 1 pi, which is 180, plus another 5/6 of pi, which puts us right here. Now, when I drop a perpendicular to the x-axis, that takes another 1/6 pi, or pi over 6, which I know is a 30-degree angle. And I know from my first quadrant, 30 degrees, the coordinates are going to be root 3 over 2, comma 1/2. But in the fourth quadrant, the y is negative. You can see we're going down there. Now, the cosecant is the reciprocal of the sine, right? And we know that on the unit circle, the sine is the y coordinate. So the sine would be negative 1/2. The cosecant's the reciprocal. So this is going to be equal to negative 2. Okay, for number 3 now, what's the cosine of 2 pi over 3? Well, if I was going to do this problem, 2 pi over 3 is like 2/3 of pi. So we're going about 2/3 of pi, which is right here. We drop a perpendicular, that reference angle is going to be 1/3 of pi, or pi over 3, or 60 degrees. And we know from the first quadrant that the coordinates for a 60-degree angle are going to be 1/2 square root 3 over 2. But in the second quadrant, because you're going to the left for the x-coordinate, that's going to be negative. You're going up for the y-coordinate, that's going to be positive. The cosine on the unit circle is associated with the x-coordinate. So this is going to be equal to negative 1/2. And then for number 4, the tangent of 7 pi over 4, what would this one be? Well, 7 pi over 4 is like 1 3/4 of pi. So I'm going 1 pi, which is 180, plus another 3/4 of pi. That puts me right here. If I drop a perpendicular, that reference angle to the x-axis is 1/4 of pi, or pi over 4, which is equal to 45 degrees. And we know the 45-degree coordinates are going to be root 2 over 2, root 2 over 2, but in the fourth quadrant, the y-coordinate's negative because we're going down there. The tangent is the ratio of the y divided by the x. Anything divided by itself is 1. A negative divided by a positive would be a negative 1. So let me erase the whiteboard and let's go on to the next group of problems. If you can pause the video and do number 5, 6, and 7. So for number 5, it says find all the 6 trig functions of this angle theta. So here you can see we've got a right triangle. We're given these two sides 7 and 24. You can do the Pythagorean theorem, a squared plus b squared equals c squared, to find the hypotenuse, or you might recognize this as a Pythagorean triple, which means that the hypotenuse here is 25. Now you position yourself at the angle and you can use the ratio SOH CAH TOA. I'm sure you remember this from before. Sine is the ratio of the opposite side over the hypotenuse. That's 7/25. The cosecant and the sine are reciprocals of each other. So if I flip this over, I get the cosecant. The cosine is the ratio of the adjacent side over the hypotenuse, so that's 24/25. The secant is just the reciprocal of cosine. And then the tangent is the ratio of the opposite side over the adjacent, so that's 7/24, and the cotangent is the reciprocal, 24/7. So let's go to number 6 now. This one, it says solve the right triangle RST, given that angle S is 90, angle R is 48 degrees, and side R is equal to 8. So we've got a right triangle, okay, and let's just say this is R, S, and T. S is the 90-degree angle, R is 48 degrees, and the side across from angle R is little r, or lowercase r, that side is 8. So we need to find the missing components. Well, we know that angle T and angle R have to add up to 90, because 90 plus 90 is 180, and all the angles in a triangle add up to 180 degrees, so that must be 42. If we wanted to find a side S here, the hypotenuse, we could use the sine. We have the opposite side and the hypotenuse. So I'm going to say the sine of 48 degrees is equal to the opposite side 8 over side S. I'll just make a cursive S. And if I wanted to find this side here as side T, which is across from angle T, I'm just going to do opposite and adjacent. That's the tangent. So I'm going to say the tangent of 48 degrees is equal to 8 over T. Okay, now all we have to do is go to the calculator now and solve. Now, one thing that's interesting, there's a properties of proportions where you can switch these on the diagonal. So I could put S here and sine of 48 here. Same thing with T and tangent of 48. So I can interchange those on the diagonal. So side S is just going to be 8 divided by the sine of 48, which is about 10.77 if I round. And then 8 divided by the tangent of 48, make sure your calculator is in degrees. This is going to be about 7.20. And you solved the triangle. You found all the angles, all the sides in this right triangle. Okay, for number 7 now, it's a story problem. A kite is on a 300-foot long string. Okay, and it's attached to the ground, and it makes an angle of 65 degrees with the ground. So that's what's called the angle of elevation, like you're elevating or looking up the line of sight of the string here. Angle of depression would be like this if you're looking down. These are going to be congruent because they're alternate interior angles. But if I want to find the height of the kite off the ground, I can drop a perpendicular, and you can see I've got a right triangle. So what trig function ties together this angle, this side, and this side? Well, this is opposite and hypotenuse. That's the sine. So it's sine of 65 degrees equals the ratio of the opposite side over the hypotenuse. If we multiply both sides by 300 to get the height by itself, let's see what that comes out to. I'm getting 271.9 feet approximately. Let me erase the whiteboard. Let's go to the next group of problems. Okay, let's take a look at number 8 now. It says state the domain in the range of one period of y equals -2 sine 2x plus pi plus 1. So how are we going to find the domain in the range of one period? Well, let's see if we can graph this. The first thing I like to do is I like to factor out this b value, or this number that comes in front of the x, so that we can identify the phase shift. So this would be -2 sine 2x plus pi over 2 plus 1. So what I'm doing is I'm just dividing out the 2. If you distribute the 2 back in, you'll get back the 2x plus pi. Now the period, there's a formula that you probably learned before. It's 2 pi divided by b. The b value is this number that comes to the left or in front of x. 2 pi divided by 2 is going to just be equal to a period of pi. So that means if our period here is pi, if we divide by 4, our scale is going to be pi over 4 is what we're counting by. The plus pi over 2 is going to shift the graph pi over 2 to the left. Remember, whatever's grouped with the x has the opposite effect. So plus pi over 2, left pi over 2. The plus 1 is going to shift up 1. So we can kind of think of this as our new, like our new origin, okay, right over here at -pi over 2, 1. Now the sine graph it normally looks like this, where it starts at the midline, it goes to the maximum, back to the midline, you know, like so. But the negative here is going to reflect it over the x-axis. So the graph now is going to look something like this. And we're going to be starting from this new shifted origin. So I'm going to start here. I'm going to go down 2, which will put me right here, back to the midline, up 2, back to the midline, which is going to be right here. So there's one period, okay, until the graph repeats. And let's see here. I think I got a little bit off here. Let me fix this a little bit here. So this is actually going to be right here, and this is going to be right here. There we go. Okay, so now one period is going from negative pi over 2 to positive pi over 2. So that would be our domain. So let's write it like this, negative pi over 2 to positive pi over 2. Our range is going from -1 to 3, with the bracket, including -1, including 3. And that's the domain and range of just one period. Now there's more than one answer, depending on, you know, if you did more cycles, you could pick a different period or for one period for the domain. But the range will always be -1 to 3. Okay, so for number 9, write an equation for a sine function with an amplitude of 3, a period of 4 pi, a phase shift right pi, and 2 down. Okay, the way I like to think of this is these functions are in this form, y equals a sine b x minus h plus k. The a is the amplitude, so in this case that's going to be 3. The b is related to the period by this formula, period equals 2 pi divided by b. So if the period is 4 pi, we can solve for our b value by cross multiplying. So that gives us 4 pi b equals 2 pi. Divide both sides by 4 pi to get b by itself. Pi's canceled, 2/4 is 1/2, so that's our b value. And it's shifting right pi, so this is going to be minus pi. Remember, it has the opposite effect. Minus pi actually goes positive pi to the right. And 2 down, this has the same effect, -2. If it was +2, it'd go up 2. So that's our equation. Okay, for number 10 now, the point 8, -15 is on the terminal side of our angle theta. Evaluate the 6 trig functions for theta. So we had a problem like this, I think, at the very beginning, but let's take another look. So right 8, down 15, so that's going to be like this, terminal side of our angle. Drop a perpendicular to the x-axis, that gives us right 8, down 15. This is a Pythagorean triple, this would be 17. That hypotenuse is always going to be positive. And we're going to be looking at this angle here at the center of our, near the origin. Okay, so the sine is going to be the ratio of the opposite over the hypotenuse, so it's going to be -15/17. The cosecant is the reciprocal of sine. The cosine is going to be the adjacent over hypotenuse, that's 8/17. The secant is going to be the reciprocal. The tangent is going to be opposite over adjacent, so -15/8. And the cotangent is going to be the reciprocal of the tangent, so that's going to be 8/15, or you could write it as -8/15. So let's erase the whiteboard and do the next group of problems. Okay, see if you can pause the video and do these next group of problems. It says find the exact value of x without a calculator between 0 and pi when cosine of x is equal to -1/2. So essentially what this problem is speaking to is the inverse trig function. So cosine of what angle is -1/2 on the restricted domain from 0 to pi. And we know cosine on the unit circle is the x-coordinate. So where does the x-coordinate equal -1/2 between 0 and pi? Well, that's going to be right here. And this angle is going to be 2 pi over 3. So that's your answer for that one. Now for number 12, what's the sine inverse of -√2/2? Remember, when you're finding the sine inverse, you're restricted from -pi/2 to +pi/2. So you're in these two quadrants. So sine is the y-coordinate on the unit circle. Where is the y-coordinate -√2/2? That's going to be right here. Now, some students make the mistake of going all the way around and saying this is 315 degrees or 7 pi/4. When you end up in the fourth quadrant like this doing the inverse sine, you want to make this a negative angle. So this would be -pi/4 or -45 degrees. For 13, what's the tangent inverse of -√3? Again, when you do the inverse trig function for tangent, it's the same as the restricted domain for sine inverse. It's also going to be from -pi/2 to +pi/2. Tangent's the ratio of the y divided by the x, and that's going to occur right here at this point 1/2 negative square root 3 over 2. When you take a tangent, you take the y over the x, that's going to give you negative square root of 3. This angle is a negative 60 degrees, or you could say negative pi over 3 in radians. You don't want to make the mistake of saying 300 or 5 pi over 3. When you're in the fourth quadrant like that, you just want to make it a negative angle. That's the restricted domain. And so for 14 and 15, we're getting into a little bit of graphing now. How do we graph the sine and the cosine graphs here with transformations? There's a lot of different ways to graph these. I'm sure you learned different methods with your previous math classes. The first thing I like to do is to figure out the period, and I take the number that comes to the left or in front of the x. In this case, it's like a 1, and I use the formula period equals 2 pi divided by b. If b is 1, our period is going to be 2 pi. Then I divide it up into 4 pieces. So if I divide by 4, this is a scale of pi over 2. And then now we can see this graph has shifted right pi over 2 and up 2. So right pi over 2, up 2. That's kind of like my new origin. I can kind of think of it as my new like x and y axis going through there. And I know the basic shape of my sine graph with an amplitude of 1 is going to look like this. Starts at the midline, goes to the maximum, back to the midline, down to the minimum, back to the midline, and that completes one period or one cycle. Again, I can continue this if I want to go a little bit further, and I can do more of the graph. Now for number 15, same thing. Period equals 2 pi over b for sine and cosine. 2 pi divided by 1/2 is actually going to be 4 pi, because when you divide by a fraction, it's like multiplying by the reciprocal. If I divide that period into 4 pieces, that's my scale. I'm counting by pi here. And then the amplitude is 2. It's not shifted left or right, not shifted up or down. I know the cosine graph starts at the maximum, midline, minimum, midline, back to the maximum. So that completes one period or one cycle. And if you want to do more, you can repeat the process, keep going. So let me erase the whiteboard. Let's do some more problems. These next 4, we're going to do some more graphs of trigonometric functions. If you need help with any of this, you can take a look at my YouTube channel, Mario's Math Tutoring, and I go through more detail of how to work with these trig functions and transformations. But we're just practicing here to see what we remember and what we need to practice. How would you graph this one? Y equals negative 2 cotangent of x. Well, for tangent and cotangent, the period is pi. So we use the formula pi divided by b. In this case, the b value is 1. Pi divided by 1 is just going to be pi. Now with cotangent, we have our asymptotes right here on the y-axis, and it repeats every pi. So pi, 2 pi, 3 pi. The cotangent graph goes down to the right, but here you can see the negative is going to reflect it, and the 2 is going to be a vertical stretch by a factor of 2. So instead of going down to the right like this, it's actually going to go up to the right, and you're going to be here at 2, negative 2, and right through the x-axis like that. So that's kind of like one basic period there. And again, you can repeat it, and it keeps repeating. So let's do number 18 next, because the tangent graph, what's interesting about the tangent is half the graph's on the left, half the graph's on the right. And we use the formula pi divided by b. Pi divided by 1/2 is going to be 2 pi. If we cut that in half, these asymptotes are going to be at pi and negative pi. Usually they're at pi over 2 and negative pi over 2. The 3 is going to stretch the graph, so it's going to go up to 3 and down to negative 3, and it goes through the origin. Tangent goes up to the right like this. Cotangent normally goes down to the right, and it's to the right of the y-axis. So normally it goes down like this, but it's been reflected in this case. Tangent, half's on the left, half is on the right. So that's a little different there. And then for number 17, cosecant of x minus 2. Well, the minus 2 is going to shift the graph down 2. Okay, so you can kind of think of this as like your new x-axis. This is like your new origin. The cosecant and the sine, they're reciprocals of each other, remember? And the amplitude of the sine graph we're going to graph is 1. So what you can do is you can kind of graph the sine graph just kind of very lightly here, just to use as a guide, okay? And the period, see, what I'm basically looking at is graphing y equals sine of x minus 2. The period is going to be 2 pi, because 2 pi divided by 1 is 2 pi. The scale is going to be a pi over 2 if I divide by 4. And then remember, sine and cosecant are reciprocals. So wherever sine is equal to 0, 1 divided by 0 would be undefined for the cosecant. So wherever it's crossing this midline is where our asymptotes are going to be for our cosecant graph. Okay, and then the way this works is that the cosecant and the sine, they coincide at the maxes and the mins, or where the graph bends, but it's going to bend the other direction. So our actual graph for cosecant are these kind of U-shaped portions of the graph here. The sine we're just using as a guide. But again, wherever it crosses that midline, the sine graph, that's where your asymptotes are going to be, your vertical asymptotes. Same thing with secant. It's the reciprocal of cosine. So I'm going to think about what would the -2 cosine pi over 2 x minus 1 graph look like. Well, the period is 2 pi divided by b. In this case, the b is pi over 2. So that comes out to 4. When you divide by the pi over 2, you multiply by the reciprocal. So a period of 4. If I divide that up into 4 pieces, that means we have a scale of 1. This x minus 1 is going to shift the graph right 1. So we're going to kind of think of this as like our new y-axis, our new origin. And then the -2 is going to reflect the cosine graph. Normally the cosine starts at the maximum like this. Now it's going to start at the minimum and go like this. So that means our graph is going to be like right here. And then it's going to go, actually, sorry, this is going to be the origin, so it's going to start right here. Erase that, right here. And then it's going to go up to the midline, up to the maximum, back to the midline, down to the minimum. So that's like our basic cosine graph here that's been reflected. We can draw a little bit more of it, like this. Now, wherever it crosses the midline, the cosine crosses the midline, that's where your asymptotes are going to be for your secant graph. So that means it's going to be right here on the y-axis, right here at 2, right here at 4. But the actual graph that we're interested in is this secant graph right here. I'll try to make it a little bit darker for us. There's a lot in graphing the trig functions, so I would definitely check out my videos on graphing all these trig functions. But we're just kind of reviewing, trying to see what we're... See if you can pause the video and do these next 4 questions, and we'll go through them together. This one says, write a cosine function given the maximum and the minimum. So the maximum is at the point 1, 5, and the minimum is at the point 9, 1. So again, when we're graphing or writing the equations of these sine and cosine functions, I think of them in the form a cosine b x minus h plus k. Now, one thing that's helpful is sometimes you can sketch in like a midline here, and the amplitude is the distance from the maximum to the midline or the minimum to the midline. But notice how that midline is exactly halfway in between 5 and 1. So if we take the average, 5 plus 1 is 6 divided by 2 is 3, that makes sense because 3 plus, so if this is at 3, let's write that down, y equals 3. 3 plus 2 is 5. 3 minus 2 is 1. So that means our amplitude is it's 2 from the midline. So this is going to be y equals 2 cosine. Now, normally the midline is right on the x-axis, but that's shifted up 3 now. So that's our k value, plus 3. And then the period, now notice this is like half of a cosine graph. So from the max to the minimum, that's like half a period. So from x value of 1 to x value of 9, that's 8. A full period would be 16. So if our period is 16 and we have the formula 2 pi over b, we can cross multiply here. 16b equals 2 pi divided by 16. B equals 2 pi divided by 16, which is pi over 8. So that's our b value. And normally the cosine starts right at the y-axis like this. So this maximum would be right here on the y-axis, but you can see that's been shifted left 1. So this is going to be x minus 1. So this is one possibility. Now I say it's one possibility because, you know, the cosine graph repeats. The a value, the period, and the vertical shift will be the same, but this phase shift could be different depending on where you want to start that cosine graph. You could start it here or, you know, another period to the left. So let's look at number 21 now. We're converting radians to degrees. This is kind of an easy one. Remember, there's pi radians for every 180 degrees. Or you could use the conversion factor, 180 over pi, so that the pi radians cancel. 9 goes in here once, 9 goes in here 20 times. 7 times 20 is 140 degrees. Now, if you were converting the other way from degrees to radians, I'd multiply by pi over 180 instead of 180 over pi. For 22, we're finding this central angle of this circle in radians. So how would you do that one? Well, there's a formula that you want to memorize, and that's that theta is equal to the arc length, S, divided by the radius, R. So that angle in radians is always the ratio of the arc length. In this case, it's 20, divided by the radius, which is 12. And if I reduce that down, let's see, 4 goes in here 5 times, 4 goes in here 3 times. It's 5/3 radians. Okay, it's like 1 2/3 radians. So you'll also probably remember the formula S equals R theta. If you were to multiply both sides of this equation by R, you would get this formula. The arc length equals the radius times the central angle, but it has to be in radians. For 23 now, how would you find an equation of an asymptote that's in the domain 0 to 2 pi of this secant graph? Well, we know the secant and the cosine are reciprocals of each other, and we know that the period is equal to 2 pi divided by b. 2 pi divided by 1/2, we've had that a few times I think today, that's a period of 4 pi, which means that our scale is pi. And if we graph a -4 cosine 1/2 x, that would be a cosine graph that starts here and looks something like this. But wherever it crosses the x-axis, that's where cosine is 0. Secant's the reciprocal of that, so that's 1/0, that's undefined. So we would get an asymptote right here at pi, 3 pi, 5 pi. But the actual secant graph looks like this, where it's actually bending the other direction. We're just using the cosine graph as a guide. But notice there's that asymptote right at pi. That's in between 0 and 2 pi. So our equation of our asymptote would be x equals pi. Let me erase the whiteboard. Let's do a few more. Do these last few problems. Go ahead and pause the video, see if you can do these on your own. And if you're enjoying this trig review and you liked what I teach and you want to learn more, I've got an Algebra 1 and an Algebra 2 video course for sale that goes through a lot of trigonometry concepts in that Algebra 2/College Algebra course. You can check that out. You can also join the channel as a member. And if you join at the additional videos level, you can get access to some of my midterm and final exam reviews, especially pre-calculus midterm and final exam review, which will probably be useful to you. So check that out. Let's do these last problems together, or you can do them on your own and we'll go through them together. How would you graph the sine inverse of x? Y equals sine inverse of x. Well, we know what the sine graph looks like. It basically looks something like this, where you start at the midline, you go up to the maximum, midline, minimum, back to the midline. That's one period. You can also go the other direction like this. But we know that the sine inverse is restricted from -pi/2 to +pi/2. So we're just basically looking at this part of the graph right here. Okay, that's the restricted domain because it passes the horizontal line test between -pi/2 and +pi/2. So if we want to find the inverse, you reflect it over the line y equals x. In order to do that, you just interchange the x and the y coordinates. So if I take this point pi/2, 1 and flip it, I'm going to get 1, pi/2. Now pi/2 is about 1.57, which would put us right about there. And at 0, 0, this point right here at the origin, that's still going to be 0, 0. And at -pi/2, -1, if I interchange those, I'm going to get -1, -pi/2, which is -1.57. And the graph's going to look something like this right here. So that's your sine inverse graph. It just goes between -1 and +1. You don't draw arrows, it doesn't continue. So it's just that piece right there. If secant of theta equals 2√3/3 and cotangent of theta is less than 0, find the sine of theta. So where is secant positive? That's going to be in the first and fourth quadrants. Where is cotangent less than 0, meaning negative? That's going to be in the second and fourth quadrants. Looks like we're overlapping here in the second quadrant, so that's where our angle is going to be. Now, the secant and the cosine are reciprocals of one another, so that means that the cosine is going to equal 3 divided by 2 square root of 3. If I rationalize this, I get 3√3/6, which reduces to square root 3/2. So if the cosine is square root 3/2, that would be adjacent over hypotenuse. If we do the Pythagorean theorem, that would be, let's call this y. That's y squared plus square root of 3 squared equals 2 squared. So that's y squared plus 3 equals 4, which means that y squared equals 1. Take the square root. y is equal to plus or minus 1. This will be a negative 1 since you're going down, you're in the fourth quadrant. And sine is the opposite over hypotenuse, so the sine is going to equal negative 1/2. Now, if we want the bonus question here, last question, find one positive angle and one negative coterminal angle with 7 pi over 5. So coterminal, co means same, terminal means where it terminates or stops. 7 pi over 5 is somewhere over here. But if we add 2 pi, that's like one revolution, you'd end up or terminate in the same spot. Or if you subtract 2 pi, you'd go the other direction, you would terminate or end up in the same spot. So all we're going to do is add 2 pi, or we're going to subtract 2 pi, and we'll have to get common denominators, so let's multiply by 5 over 5. So this gives us 7 pi over 5 plus 10 pi over 5, which is 17 pi over 5. That's one positive coterminal angle. 7 pi over 5 minus 10 pi over 5 is negative 3 pi over 5. That's one negative coterminal angle, and you got it. So great job if you're able to benefit from this trig review. Of course, there's a lot of topics in trigonometry, and you can check more of those videos out on my Mario's Math Tutoring YouTube channel if you want to learn more about trigonometry. I can put a link to a playlist over there if you want to head over there and search up some other videos or topics you're interested in. I'll see you in my other videos.